Hello friends, now we are starting with chapter number 12, Electromagnetic Induction. I think this series is definitely helping you because I am trying to reduce as much as I can reduce it. And the important part which I am giving to you is really very important. Please don't ignore any part, and especially IOPians. You know that I have taken type-wise numerical. Though I am telling something about numericals, but this is my humble request to all of you that please go through type-wise numericals which I have already solved in the class. Now, in electromagnetic induction, EMI, very interesting chapter. First important part for the theory is Faraday's laws. We know that electromagnetic induction E induced in conductor is always directly proportional to change in magnetic flux. This is very important. We can have the law for the cause of induced EMF and the magnitude of induced EMF. Third part is very important. See, जिसने पैदा किया उसी को मारने का काम और जो मर रहा है उसे बचाने का काम. In short, Lenz's law, which is in accordance with the law of conservation of energy. See, I am telling all these small facts because small questions or small MCQs can get developed on these special points. Okay, so the next is what? Right hand thumb rule. When current is flowing through the conductor in the direction of thumb, then curl finger gives idea about the direction of magnetic field. Okay. Next is very interesting. When a conductor is moving in uniform magnetic field, due to change in flux, there is induced EMF. Due to change in flux, there is induced EMF in a conductor, and famously I call it as Bharat is a land of vision. That means E is equal to BLV, where E is induced EMF, B is magnetic induction, L is length of the conductor, and V is velocity of moving conductor. Okay, that expression is very important. Next expression might be there will be a numerical on this or derivation, and that expression is for rod. If a rod is fixed at one end and it is revolved or rotated in a uniform magnetic field, then induced EMF E is equal to B half B L square omega. This expression is important and is important for numerical also. You will have numerical on this expression for 1 mark. Okay, next is working and principle of generator. Very important point. Diagram is also very important. Then short note on eddy current, or there will be a question on application of eddy current. Next part is about inductance. Coil. When current flows through the coil, due to resistance there is variation in the coil itself and gives rise to the change in flux and induces EMF, which causes induced current. Okay, self-inductance I am talking about. You know the theory part. So that part is very small and very easy to remember. But energy stored in the conductor is half Li square. That expression is important. Numerical, for numerical also it is very important. Half L is self-inductance. I is I square of the current through the conductor. Okay. The next is energy density. In case of inductor, energy per unit volume is called as energy density, and that expression half mu 0 n square I square, where mu 0 is permeability, n small n represents number of turns per unit length square, and I square is what? Square of current flowing through it. Then the next important point in this chapter is comparison between self-inductance and mutual inductance. That is also basic part of a transformer. It is also important for numerical. Small numerical can be developed or can be designed. And in case of transformer, you know that transformer ratio is ES, EMF induced in the secondary, to the EP, EMF induced in the primary. This ratio is always equal to the ratio of number of turns in the secondary to the number of turns in the primary. This is also known as transformer ratio. No problem for I mean to say that transformer can be step up or step down, but the expression will remain same. Okay, these examples are very important. And normally, see, there will be example on E is equals to minus d phi by dt, where flux is directly given, and just differentiate it. Sometimes flux is given in the form of a function. Use the derivative formula and find the EMF induced in it. For self-inductance, numericals are based on expression E is equal to L di by dt, where di by dt is the rate of change of current in the primary coil or in the inductor only. In case of mutual inductance, current flowing through coil 1 changes the flux of second. In that case, E is equal to minus M. M is mutual inductance. M di by dt, where again di by dt is